So in this video, we will study about edge, screw, and mixed dislocation. We had seen what is a dislocation vector and demarcated between slip and non-slip region. So let us draw it once more. So we have drawn this as the dislocation vector, and in this region there is no slip, and you have slip in this region. Okay, and we have seen the slip occurs toward in a perpendicular direction that is shown by the Burgers vector. And this Burgers vector you can see will give you the magnitude and direction of the slip. This gives you the magnitude and direction of the slip. Okay. And direction of slip. So this is given by this B. Okay. Now you can see that this Burgers vector is perpendicular to the dislocation line or the tangent vector. That is the vector that is tangent to the dislocation line. But this is no. So this is called the edge dislocation. Edge uh, dislocation. This is called edge dislocation. And now we will see what you mean by a screw dislocation. Screw dislocation. In a screw dislocation, you have the same dislocation vector. So this is the dislocation vector, and here this is the no slip region, and here this is the slip region. So here you can see that this the dislocation line. So this is the dislocation vector, Burgers vector. Okay, this is the Burgers vector. You can see that this Burgers vector is parallel to the tangent vector. So that means the slip occurs parallel to the dislocation line. The slip occurs parallel to the dislocation line. So in this way, for this slip, we call it screw dislocation. It is just like uh, twisting the atoms along the dislocation line. Okay, with dislocation line as the axis. That is why this is called a screw dislocation. And then you have the mixed dislocation. Mixed dislocation. In a mixed dislocation, you have again the dislocation vector. Uh, so these classifications are based on the angle between the Burgers vector. So this is the tangent vector, and this here the Burgers vector is not perpendicular nor parallel to the tangent vector. It is not perpendicular and not tangent. So in this case, the Burgers vector will be at an angle here. Okay. And so here there is Burgers vector here. So the dislocation just appears like this. Okay, so this is the dislocation vector B. Okay, we have a dislocation like this. Okay, and this is called the mixed dislocation. So this classification is mainly based on all these classifications are mainly based on the angle between dislocation, Burgers vector, and dislocation. Right. So these are the three different types of dislocation. So the first one is the edge dislocation. Then you have the screw dislocation, and then you have the mixed dislocation. Uh, okay, now we can see the various pictures of screw dislocation and edge dislocation. So this picture is that of a screw dislocation. Okay. So here you can see that see the Burgers vector is shown by this line. So this is the Burgers vector. For that we have different color. Uh, this is the Burgers vector. So this is the Burgers vector, and the dislocation line here is this one is the dislocation line. So you can see that the Burgers vector here is uh, parallel to the tangent vector or dislocation vector. That is why you are getting a screw-like dislocation here. So it is twisting around the dislocation line. So that is why this is called a dislocation. So here you can see the difference between edge dislocation and screw dislocation in detail. So the first one is that of the edge dislocation. You can see that here the top half the top half is displaced towards the right. Okay. So this is the so here the dislocation moves in the direction of the applied shear stress. So here the Burgers vector is perpendicular to the tangent vector, and you can see the screw dislocation here. So initially you can see that it is just trying to rotate here. So, and finally you will get the exact sleeve similar to the first one, but here actually the first here it rotates here and then it spreads up to here. So that's what happens. So this is the screw dislocation. So we will look at one more picture here. So this makes it much more clear. So here You can see the edge dislocation here. This is the bottom edge of the extra half plane. So this is the extra half plane. This is the bottom edge. So this is the edge dislocation. Here you can see here this is a screw dislocation. So you can find that here the Burgers vector is parallel to the disk tangent vector. So these are the differences between edge and screw dislocation. So we will look at in much more detail by using the Burgers circuit.